Hey guys, so we are going to do the second part of your Chapter 3 test, starting on the back page, questions 12 through 23. Just going to start here on 12, 13, 14. Directions are the same. It says solve the inequality. So that means get your variable by itself. So here on 12, my variable is x. To get it alone, I have to move minus 3. The opposite of subtraction is addition. So let's add 3 to both sides. This gives me x greater than 10. And that's it. There's no graphing, just solving it. 13, same idea, getting our variable. This time it's m by itself. To get m by itself, I have to move plus 2. The opposite of addition is subtraction. So I'm going to subtract 2 from both sides. That gives me m less than or equal to negative 4 minus 2. I'm getting more negative, so I get negative 6. I have not multiplied or divided by a negative number, so I do not need to flip any inequality symbols. 14. To get my variable by itself, I have to undo this 6. Well, the way my 6 is connected is actually secret operation of multiplication. So to get y by itself, I'm undoing multiplication with division, and I have to divide by 6 because that's what's attached to my variable. So I have to divide 6 on both sides. This starts out with y greater than 8 over 6. Now, if you leave your answer as a fraction, it has to be simplified. To simplify, I have to think of a number that 8 and 6 have in common that I could divide. Well, they're both even, so a nice little number I always like to use is 2. If I divide top and bottom by 2, this gives me 4/3. And then there's no other number that I could divide out to simplify my fraction. So if you leave your answer with fractions, you could say y is greater than 4/3. That's definitely one answer. I saw a lot of you want to do decimals, and that's fine. If you did decimals, it actually is a repeating decimal. This is y is greater than 1.3 repeating. Some of you just rounded to the tenths or the hundredth spot. Or you have y is greater than 1.3 or 1.33 if you round. Any of these were acceptable answers. I personally prefer fractions, but that's just me. And if you did decimals, here are equivalent answers. Okay, finishing up this section, 15, 16, 17. We're still solving our inequality, not graphing anything. 15, to get our variable p by itself, we're undoing division. So to undo division is multiplication, so I'm going to multiply. I'm going to multiply by 5 because that's what's attached with my p. Multiplying on 5 on the left and on the right. So I've got to be fair. This gives me p less than. Now, I'm not multiplying by a negative number. 5 was positive. So this inequality symbol stays the same. Negative 3 times 5, well, negative times a positive is a negative. 3 times 5 is 15. You do not need to flip that inequality symbol. 16, this is more of a two-step inequality, so we have to think of it like an equation. To solve two-step equations, we undo addition and subtraction first, and then we move to undoing multiplication and division. So my 4z can't move right now. We have to undo subtraction. Undoing subtraction, we use addition. So we're going to add 3 to both sides. This leaves me with 4z. Haven't multiplied or divided by a negative number, so the inequality stays the same, so greater than or equal to negative 1 plus 3. That's positive 2. I'm at negative 1, moving forward, positive 3 gets me to 2. To get z by itself, I have to undo a secret operation of multiplication using division. So I'm going to divide by what's attached, which is 4. Divide by 4. This gives me z greater than or equal to 2/4. Now, fractions have to be simplified. 2/4 can be simplified by divide. 2 is in common with 2 and 4, so if I divide top and bottom by 2, I get 1/2. So your final answer should be z greater than or equal to 1/2. Or if you wrote it as a decimal, you can have z greater than or equal to 0.5. Either are acceptable answers. But if you didn't simplify your fraction, you just lost half a point. Need simplified fractions. 17. 17 was an example of an and problem. Oops, I keep doing that. Goodness. And problem, where everything is connected. This is what I like to call a smooth inequality. It's connected from left to right. To solve it, we're getting the variable alone in the middle, and we're undoing things on the right side and on the left. So to get t by itself, like I did in these other problems, I have to undo what's attached. Well, attached is plus 2. To undo addition is subtraction, so I subtract 2. I can't just do it to the middle, but I have to do it to the right, and I have to do it to the left. This is like a big scale. I have to be fair. So this leaves 3 minus 2. Well, that's just 1. The inequality symbol doesn't change. It carries down. Less than. T is alone. Inequality symbol doesn't change. Less than. 6 minus 2. That's 4. This is your inequality statement. No multiplying or dividing of negative numbers. That's why the inequality symbols stayed the same. Again, if you're still struggling with this, please come see me in 7th period for help. Okay, 18, solve the inequality and graph the solution. So I'm actually going to rewrite my problem below my number line. That's where I have space. Negative 4 plus x less than or equal to 1. To solve my inequality, I'm getting my variable by itself, so I have to move minus 4 to undo subtraction as addition. So I'm going to add 4 to both sides. That gives me x less than or equal to 1 plus 4 is 5. Again, no multiplying or dividing happened of negative numbers, so I can leave the inequality symbol the same. So to plot this, 5 is going to go in the middle. You guys know me, I like silly numbers that are bigger and smaller. A nice smaller one is 0, so I guess that's not silly, but let's just put 0 right here. And then a nice like positive number, it could be silly, it could be like 200. 200 is definitely more than 5. The inequality symbol here, we have less than or equal to. That means closed circle. Less than or equal to means I'm pointing to all the numbers smaller than 5. That means I'm drawing my arrow towards that 0. Remember, answer is not complete without the solved inequality and this graph. 19, still doing the same thing. We're solving our inequality and graphing the solution. So I'm going to rewrite it down here to less than negative y over 5. Now, let me rewrite that negatives out front here. If you guys remember, at the beginning of the year, I told you when there's a negative in front of your fraction, attach it to your denominator. It makes things a little bit easier. So to rewrite my problem to address this concern I had, I have 2 less than y over negative 5. It makes it easier. If I attach it to a number, I don't have to worry about getting my y positive and dividing by a negative 1. It just kind of takes away that step for me. But here, to get our y by itself, we're undoing division. Remember, fractions are division problems, so to undo division is multiplication. To get y by itself, I'm dividing by this negative 5. This right here is when we're going to have to flip our inequality symbol. If we multiply 5 on the right, we have to multiply 5 on the left. But because I multiplied by a negative, this inequality symbol changes and flips to be greater than. So on the right, I have y alone, which is what I want. Negative 5 times 2. That's negative 10. So this right here is your inequality statement, negative 10 greater than y. Now if you remember, I don't really like my variables on the right, but I would never mark off if you left it like this. I like my variables on the left, so I can rewrite this as or y less than negative 10. It means the same thing. How do I know it means the same thing? Well, what if I checked? What if I picked a number from my original inequality and plugged it in? Negative 10 greater than y. So let's just pick some number that is smaller than negative 10, like negative 11. Negative 11 is smaller than my negative 10. Negative 10 is definitely more than that because negative 10 is closer to 0 than negative 11. Let's see if that holds true on the right. If I plug in negative 11 less than negative 10, that's a true statement. So these are actually the same. So when I'm graphing, I have to be very, very careful about where my arrow is going to be. First, I'm going to plot negative 10 in the middle. Because you guys know me, I like to plot it in the middle. The inequality symbol is strict, which means there's no line underneath. So it's an open circle. Let me put some numbers, put some reference. So let's pick a number that's pretty obviously greater than -10, that's 0. Let's pick a number that's obviously smaller than -10, like -20. Now, let's think. I use an example of my plugging in a number y and making a true statement. This is saying that my -10 is more than every other number. So, my arrow has to point to everything smaller or to the left of my -10. This is the correct graph. A lot of people made mistakes on the graph. Some of you forgot to flip your inequality symbol. Be very, very careful of this. This is why we practice. That's why it was on your cheat sheet. Should have written it on a note card. Let's move on. Number 20. This is an absolute value inequality. This is the only absolute value inequality. I'm going to rewrite it down here, so I got some space. 3 times 4x plus 2, or the absolute value of 4x plus 2 greater than or equal to 6. Now my first step when I have absolute values, regardless, is to get this absolute value alone. It's not alone right now. This 3 is here. I don't like the 3. I need to move it. Remember, this is not a distributive property. These are not parentheses. You cannot do the same thing as you would if they were. So 3 is actually connected with a secret operation of multiplication. I don't want it there. So I have to undo it with division. I'm going to divide by 3 on both sides. This leaves the absolute value, 4x plus 2 by itself, which is exactly what I want, greater than or equal to 6 divided by 3 is 2. Now we have an greater than or equal to. This is an or, which means I split my problem to I split my absolute value into 2 problems connected with or. The first problem is if I imagine I took away the inequality symbol. So I just had 4x plus 2 greater than or equal to 2. The second problem, remember we don't ever change anything inside the absolute value. You just have 4x plus 2. What changes is the inequality symbol. It turns to be the opposite direction, so less than or equal to. And you change this 2 to be the opposite. So right now it's a -2. And we're just going to solve these 2 inequalities. Question 1, we're going to get our x by itself, undo addition and subtraction first. So that's subtracting 2 from both sides. That gives 4x greater than or equal to. 2 minus 2 is 0. Not too bad. A lot of times I got scared. It's okay to have 0. Just not okay to have 0 in the original problem. Solving for x, we're undoing secret operation of multiplication. So I'm going to use division. 0 divided by 4. That's allowed in math. It's the other way that's not. So 0 divided by 4, that's just 0. So one solution is x greater than or equal to 0. Or, let's solve question 2. Same idea, getting our x by itself, undoing addition, subtraction first. So to undo plus 2, I subtract 2. This gives 4x less than or equal to -2 minus 2 is -4. Now to get x by itself, I'm doing secret operation of multiplication with division. So I'm going to divide by +4. This now gives x less than or equal to, the inequality symbol is not changing. It did not divide by a negative. -4 divided by positive. A negative divided by a positive is negative. 4 divided by 4 is 1. So my answer, or my solution, is actually 2 inequalities. It's x greater than or equal to 0, or x less than or equal to 1. This is when the arrows point away from each other. So let me go back up here. Let's plot these numbers. I have, let's say, -1 right here, 0. Let's just do some normal numbers. Let's have 1 and -2. Regardless, the dots I'm going to draw are both closed because I have the inequality symbol with a line underneath it. So those closed dots over -1 and 0. And they're just pointing opposite directions. So 0 needs to point to all of the numbers more than it. So pointing towards +1. And for my -1, I'm pointing to all the numbers less than it. So I'm going to point to -2. This is your correct graph. If you did not have the rule written down on your inequality, on your your note card, then this probably caused some issues for you. I'm going to have to pause this video, guys, and make another one for the last couple questions. Sorry about the 3 videos. It's just because of timing and how it's working out. But here's at least through that section.